Hey everyone, and welcome. All right, today we are going to tackle a super powerful tool with let's be honest, a kind of complicated name, Latent Dirichlet Allocation, or just LDA. You ever wonder how some websites or apps just seem to know what you're into? Well, a lot of the time, the secret sauce is an algorithm just like LDA. It sounds heavy, I know, but I promise, by the end of this, you'll get the simple, really elegant idea behind it all.
So let's just imagine for a second. You've got this mountain of text. I'm talking a million news articles, maybe a billion tweets, whatever it is. How on earth do you even begin to figure out what's in there? I mean, you can't read it all, right? So what do?
You teach a machine to read. Now, we're not talking about reading in the human sense, with understanding and all that. No, you teach it to do something that, for this job, is way more powerful. You teach it to find the hidden patterns, the secret themes that tie all of that text together. And that, right there, is what LDA is all about.
Okay, so here's our game plan. First, we're going to talk about this problem of basically drowning in data. Then, we'll get into how we can actually teach a machine to find themes. After that, we'll peek under the hood and see how LDA thinks, check out where it's being used in the real world, and finally, we'll wrap up with why this thing is so good at finding structure in all that chaos.
I mean, think about it. We are literally swimming in an ocean of text every single day. You've got your social media feeds, constant news updates, customer reviews for everything under the sun. The amount of messy, unstructured data out there is just staggering. And finding the important stuff, the actual signal and all of that noise, is a huge, huge challenge.
So what's the life raft in this ocean of text? Well, it's a technique called topic modeling. You can think of it as a way to let an algorithm scan through massive piles of documents and automatically sort them out based on the underlying themes or, you guessed it, topics inside. It's like having an automated librarian for our entire digital world.
And the undisputed king of topic modeling is LDA. Okay, I know, that definition looks super academic and kind of scary, but trust me, we can break this down. Generative just means the model imagines a story for how the documents were created. Statistical, well, that just means it's all based on probability. And the key part, unobserved topics, refers to those hidden themes it finds all by itself. Themes we might not even have known to look for.
Let's make this real. Say the model is churning through thousands of news articles. If it keeps seeing words like president, government, and election showing up together again and again, it starts to make a connection. It's kind of like it's thinking to itself, these words seem to hang out together a lot. They must be part of the same theme. Now, it doesn't know to call that theme politics. We humans add that label later, but it does the heavy lifting of finding that group of words for us.
And this is really the core idea, the big aha moment of LDA. The model sees words like dog, puppy, and bark together and says, okay, that's a topic. It sees cat, kitten, and meow together and says, that's another topic. So the whole concept boils down to this. Any given document is just a mix of different topics, and every topic is just a bucket of words that tend to appear near each other. Simple, right?
All right, so how does the magic actually happen? To really get LDA, we have to understand its generative story. It's this cool imaginary process it runs where it pretends it's the one writing all the documents. And by working that process in reverse, it figures out what the topics must have been in the first place.
It's really just a three-step recipe. Let's pretend you are the LDA algorithm. First, you're about to write a document, and you decide, okay, this one is going to be, let's say, 70% about dogs and 30% about cats. That's step one. Then, for every single word you need to write, you basically flip a weighted coin. You're probably going to pick the dog topic most of the time. That's step two. And finally, once you've picked a topic, say dogs, you just pick a word from that topic's word list, like bark. That's step three. You just do that over and over, and bam, you've got a document. LDA simply looks at the final documents we give it and works backward to figure out the original recipe.
Whoa! Okay, don't panic when you see this. I know it looks like something out of an advanced math textbook, but it's really not that bad. This is just the official, scientific blueprint for that simple three-step recipe we just walked through. All those boxes and Greek letters, they're just the technical way of showing our documents, the words inside them, and the probabilities that glue it all together. It's just the fancy version of our dog and cat story.
Okay, theory is great, but where does the rubber meet the road? Where do we actually see LDA in action out in the real world? Well, the applications are all over the place. And honestly, the story of how LDA even came to be is pretty fascinating.
And this is where the story gets really, really cool.
LDA was not invented for text at all. It first showed up back in 2000 to solve a problem in, of all things, population genetics. It was used to find hidden structures in the genes of different groups. It took 3 more years for some brilliant computer scientists to look at that and go, wait a minute, we could use that exact same idea to find hidden topics in documents. What a leap!
And from there, it just took off. The applications today are just wow. Social scientists use it to make sense of millions of tweets during a public health crisis. Psychologists have used it to find common themes in how patients describe themselves. People have even used it on music to find underlying tonal patterns. The data is different, but the core idea is exactly the same. Find the hidden structure.
So what's the big deal? Why did LDA become the rock star of topic modeling? What made it so special? Well, to get that, we need to take a quick look at the model that came right before it.
So, LDA was a big improvement on an older model called PLSA. Now, PLSA had this nasty habit of overfitting. It was kind of like a student who just memorizes the exact answers for a test, but has no idea how to solve a new problem. The secret weapon LDA brought to the fight was something called a Dirichlet prior. Now stay with me. Think of it as just a simple dose of common sense for the algorithm. It basically tells the model, hey, heads up, most documents are probably only about a few main topics, not 100 different things at once. That little bit of guidance helps it generalize way better and gives much more useful results.
And really, that's what this is all about. It doesn't matter if the data is a bunch of articles or genetic code or even musical notes. LDA gives us this incredible lens to see through the chaos. It lets us zoom out from all the messy details and actually see the underlying structure, the hidden themes that make sense of it all. It helps us find the map hidden in the noise.
So, I'll just leave you with this question. LDA is just one tool, but it's part of this bigger shift in how we understand our world. It really makes you wonder, with these oceans of data all around us, what other amazing patterns are just hiding in plain sight, waiting for the right tool to come along and bring them into focus? Thanks so much for diving into this with me.